Question 1. From the perspective of traffic flow behavior in a dual orchestrator environment, how should the security group handle failover to maintain consistent session awareness across all security group module SGMS? A. By routing only management traffic via the active orchestrator. B. By synchronizing session tables through the SMO using ECP state mirroring. C. By switching all traffic handling responsibilities to the backup orchestrator. D. By using layer 4 distribution mode exclusively. Answer. Correct answer. B. Explanation. In a dual orchestrator setup, maintaining session awareness is critical. Session table synchronization is handled by the SMO using checkpoint internal synchronization protocol, often involving state mirroring mechanisms, ensuring each SGM receives consistent state information. TCP state mirroring ensures minimal traffic interruption during failover. Option A is incorrect since it refers to management, not data plane traffic. Option C misrepresents Maestro's architecture. Both orchestrators can remain active in separate roles. Option D is traffic distribution method, not failover mechanism. Question 2. As illustrated by a recent deployment, Mr. Ibrahim configures VLANs on uplink ports and notices asymmetric routing across SGMS. What is the most likely reason and what should he do to correct this issue? SGMS lack VLAN tagging capabilities. VLANs must be untagged. B. VLANs were configured in active standby mode, which disrupts symmetry. C. VLAN configuration was done only on one orchestrator. It must be done on both. D. Failed to assign VLAN interfaces to a security group policy. Answer. Correct answer. C. Explanation. VLANs must be consistently configured across both orchestrators to ensure symmetrical traffic routing across SGMS. Asymmetric routing disrupts traffic flow and can cause session drops. Option A is incorrect. SysSGMS do support VLAN tagging. Option B is not relevant. VLANs don't have active standby modes. Option D touches policy configuration but not the root cause of routing asymmetry. This issue relates to orchestration configuration consistency. Question 3. According to recent studies of Maestro traffic behavior, what is a primary function of the correction layer in traffic distribution? A. To adjust TCP window sizes for high throughput. B. To correct interface MTU mismatches across orchestrators. C. To write hash decisions made by distribution layers for flow integrity. D. To enable OS-free distribution across VLANs. Answer. Correct answer. C. Explanation. The correction layer in checkpoint Maestro writes initial distribution decisions made by layer 2 or layer 4 distribution when flows need rebalancing for session stickiness or failover recovery. It ensures consistent traffic behavior, especially after topology or configuration changes. Option A relates to transport layer tuning. Option B is a network configuration task. Option D is an unrelated dynamic routing operation. Question 4. While configuring the SMO, Vanessa observes that the SMO master is not recognized by some SGMS. Based on the information provided, what could be the underlying issue? A. The SMO master is running an unsupported software version. B. The SMO master failed to distribute its public key to the orchestrators. C. The SGMS are not part of the same security group as the SO. D. The SMO is in read-only mode. Answer. Correct answer. C. Explanation. The SMO master must have also SGMS properly registered to its security group. If the SGMS are not correctly joined to the same group, they will not recognize the SMO master. This is often seen during deployment or misconfiguration of SGMS. Option A may cause compatibility issues but wouldn't prevent visibility. Option B refers to secure communication but not SMO recognition. Option D restricts actions, not visibility. Question 5. In contrast to conventional traffic distribution models, how does layer 4 distribution in Maestro enhance the granularity of flow allocation across SGMS? A. It maps flows to SGMS based on MAC addresses. B. It uses destination IP only to balance traffic. C. It includes source to destination IP and TCP port numbers for hashing. D. It relies solely on protocol type to determine session paths. Answer. Correct answer. C. Explanation. Layer 4 distribution uses a more granular 5-tuple source-to-destination IP and ports protocol to assign traffic flows, ensuring better session-based load balancing across SGMS. This is critical for maintaining connection persistence and reducing session fragmentation. Option A refers to Layer 2. Option B is part of Layer 3 distribution, not Layer 4. Option D lacks adequate granularity for session consistency. Question 6. During the process of deploying a dual-site environment, ISTA-LE notices latency spikes and routing anomalies. What is the most effective step to mitigate this issue within Maestro's architecture? A. Enable interface-based monitoring only on the active site. B. Configure inter-site LAC with proper heartbeat monitoring. C. Switch from dynamic to static routing on SGMS. D. Move SMO master to the backup site for redundancy. Answer. Correct answer. B. Explanation. Inter-site LAC link aggregation control protocol with heartbeat monitoring is crucial to detect and respond to link failures or congestion between sites. It allows seamless redundancy and health check mechanisms to avoid packet loss or duplication. Option A would limit visibility. Option C might reduce dynamic failover flexibility. Option D may be part of disaster recovery but doesn't address latency or routing anomalies. Question 7. Taking into account the function of orchestrators, what critical role do they play during the initial setup of the Maestro system? A. Distribute smart console configurations across SGMS. B. Provide management GUI for policies and logs. C. Handle physical interface configuration and SGM connectivity. D. Enforce identity awareness features within the environment. Answer. Correct answer. C. Explanation. Orchestrators are responsible for physical link setup, interface assignment, and ensuring SGMS are interconnected correctly. This is foundational to Maestro's functioning. They are not responsible for policy management. Option A, Smart Console. Option B, or identity features. Option D, which are roles assigned to the security management server or other blades. Question 8. Is Catalina deployed a security group with SGMS? She later observes inconsistent file sync behavior across the group. What should she verify first to ensure reliable distribution of files within Maestro? A. Confirm all SGMS are in standalone mode. B. Ensure the SMO is in active read-write state. C. Disable Gaia portal on all SGMS. D. Enable LAC on all VLAN interfaces. Answer. Correct answer. B. Explanation. File distribution across SGMS depends on the SMO's active read-write mode. If it's in read-only or standby state, synchronization processes will be impaired. Option A contradicts the premise. SGMS in group cannot be standalone. Option C is unrelated. Option D affects physical connectivity, not file synchronization. Question 9. In what ways can a security group master election be triggered unintentionally, and what is its impact on cluster stability? A. When smart event logs exceed threshold size. B. If an SGM is rebooted manually. C. If interface flaps are interpreted as node failures. D. When a new policy is pushed from Smart Console. Answer. Correct answer. C. Explanation. Interface flapping can cause Maestro to interpret a node failure, triggering a security group master election, leading to brief cluster instability or failover. This occurs because Maestro checks link health aggressively. Options A and D involve management layer activities. Option B affects one SGM, but does not necessarily cause re-election unless it's the active master. Question 10. What would happen if Maestro licensing is not applied correctly across orchestrators in a dual-site deployment? A. SGMS will default to firewall-only mode. B. Orchestrators will shut down all VLAN links. C. Only one site will remain active, disabling redundancy. D. SMO functionality will degrade, affecting cluster operations. Answer. Correct answer. D. Explanation. Maestro licenses must be applied properly across all orchestrators. If licensing is incomplete or inconsistent, the SMO may not function fully, impairing synchronization, configuration distribution, and monitoring. Option A is false. Functionality is not limited to firewall mode. Option B misrepresents hardware behavior. Option C confuses licensing issues with high availability mechanisms. Question 11. Given the circumstances that Mr. Ahmed is troubleshooting an SGM which intermittently loses connectivity to the SMO master, which of the following diagnostic steps should he prioritize to identify the root cause? A. Verify that the SGM's VLAN configuration matches the orchestrator's settings. B. Check that the SMO master is running the latest Maestro licensing version. C. Inspect whether the firewall policy on the SMO master block SGM management traffic. D. Confirm that the SGM has sufficient CPU resources to handle traffic. Answer. Correct answer. A. Explanation. VLAN mismatches between the SGM and orchestrator cause intermittent connectivity failures due to dropped or misrouted packets which directly impact SMO master communication. Option B relates to licensing, which doesn't cause intermittent connectivity. Option C is important but usually less common than VLAN misconfigurations. Option D impacts performance but is less likely to cause connectivity loss. Question 12. When considering security groups, ISPREA notices that traffic is unevenly distributed in SGMS despite layer 4 distribution being enabled. Which factor most likely explains this behavior? A. Unequal hardware capabilities of SGMS affecting hash calculations. B. Incorrect SGM membership in multiple security groups. C. Security group policy rules forcing traffic to specific SGMS. D. SMO master failing to propagate updated hash algorithms. Answer. Correct answer. C. Explanation. Security group policies can enforce traffic steering or restrictions that override default hash-based load balancing, causing uneven distribution. Option A is false as hardware differences don't influence hash calculations. Option B is invalid since an SGM can only belong to one security group. Option D is rare, as SMO typically ensures synchronization. Failure would cause broader inconsistencies. Question 13. Based on the information that Mr. O'Connor needs to perform an upgrade on Maestro deployment, what is the safest practice to minimize system disruption? A. Upgrade all SGMS simultaneously, then upgrade orchestrators sequentially. B. Upgrade the SMO master first, then orchestrators, followed by SGMS one by one. C. Upgrade orchestrators first, then SGMS while the SMO master remains offline. D. Apply upgrades to SGMS during peak hours to utilize maximum resources. Answer. Correct answer. B. Explanation. The correct upgrade sequence is to upgrade the SMO master first, which coordinates cluster configuration, followed by orchestrators via SGMS sequentially to minimize traffic disruption. Option A risks losing synchronization by upgrading SGMS all at once. Option C risks cluster management failure by leaving SMO master offline. Option D increases risk during high load. Question 14. In the context of orchestrator interfaces, what distinguishes the external management interface from the cluster internal interface? A. External management interfaces handle inter-EGM traffic. Cluster internal handles admin access. B. External management interfaces provide connectivity to external networks. The cluster internal connect SGMS internally. C. External management is responsible for internal state synchronization. Cluster internal routes external traffic. D. Both interfaces serve identical purposes but are configured redundantly for failover. Answer. Correct answer. B. Explanation. The external management interface connects Maestro components to external management networks, e.g. Smart Console logging servers, while the cluster internal interface is used solely for SGM to EGM communication inside the security group cluster. Option A swaps their roles. Option C confuses internal synchronization and external routing. Option D is incorrect. Interfaces have distinct roles. Question 15. For the purpose of designing scalable Maestro systems, Istachen proposes adding additional SGMS to improve throughput. Which underlying principle should guide the maximum number of SGMS per security group? A. The total number of SGMS is unlimited. Only hardware limits throughput. B. Network latency per SGMS should not exceed 5 ms to maintain synchronization. C. Licensing restrict SGMS to a fixed count per Maestro deployment. D. SMO overhead increases exponentially with more than 12 SGMS impacting performance. Answer. Correct answer. D. Explanation. While adding SGMS improves throughput, SMO synchronization overhead grows exponentially beyond a certain number, typically around 1 to 1 to SGMS, causing performance degradation. Option A ignores practical limitations. Option B is good practice but not a fixed principle for Maximus GMS. Option C is licensing dependent but usually less restrictive than architectural limits. Question 16. During a file distribution operation, is Emily notes that only a subset of SGMS successfully received the update? What would be the most logical cause of this behavior? A. The files were distributed before the SMO Maestro was active in read-write mode. B. The security group was in maintenance mode, blocking file sync operations. C. The files were too large and exceeded the maximum allowed size per SGM. D. The orchestrator interfaces were set to passive mode. Answer. Correct answer. B. Explanation. If the security group or SMO is in maintenance mode, synchronization tasks including file distribution are paused or blocked, causing partial distribution. Option A affects overall syncing but wouldn't allow any distribution. Option C is false. File size limits apply to individual components but do not cause partial sync. Option D impacts routing, not file sync. Question 17. Considering advanced Maestro troubleshooting, which diagnostic tool is most effective for isolating Layer 2 connectivity issues between SGMS and orchestrators? A. Maestro's clear. Show cluster status command. B. Ping and traceroute between orchestrator IPs. C. Switch port mirroring with packet capture on VLAN trunks. D. Reviewing Maestro audit logs for error messages. Answer. Correct answer. C. Explanation. Switch port mirroring with packet capture on VLAN trunks is the most direct way to observe Layer 2 frames and detect VLAN mismatches, SDP issues, or physical connectivity faults. Option A shows cluster health but not low-level link issues. Option B tests IP layer, not Layer 2. Option D helps post-factum analysis, not real-time detection. Question 18. In light of recent developments, what is the fundamental reason for implementing Security Group Module SGMS, a hyperscale Maestro environment? A. To provide distributed threat intelligence locally at each module. B. To enable parallel firewall processing and achieve line rate throughput. C. To simplify policy management by localizing rules per module. D. To act as failover nodes in case of orchestrator failure. Answer. Correct answer. B. Explanation. SGMS enable parallel processing of firewall traffic across multiple hardware modules, thus scaling throughput linearly for hyperscale performance. Option A is a feature of threat prevention blades, not SGMS specifically. Option C is false because policy management is centralized. Option D is inaccurate. A failover is managed at the orchestrator and SMO levels. Question 19. From multiple perspectives, what is a key challenge when integrating Maestro with other checkpoint solutions, such as smart event or identity awareness? A. Maestro's distributed architecture complicates centralized log collection. B. Smart event does not support SGMS as log sources. C. Identity awareness conflicts with Maestro's traffic distribution algorithms. D. Policy enforcement is disabled when using integrated solutions. Answer. Correct answer. Explanation. Maestro's distributed and scalable architecture means logs originate from multi-LSGMS SGMS and orchestrators, complicating centralized log collection and correlation in solutions like Smart Event. Option B is incorrect as SGMS can send logs. Option C is false. Identity awareness works independently. Option D is wrong as policy enforcement remains active. Question 20. A key distinction between Maestro's single management object SMO and traditional cluster management is that the SMO operates only at layer 3 and above, ignoring layer 2 states. B acts as centralized state synchronization and configuration point for the entire security group. C is optional and replaced by orchestrators in small deployments. D requires manual failover by administrators during node failures. Answer. Correct answer. B. Explanation. The SMO serves as the centralized state synchronization and configuration authority for OSGMSA, a security group ensuring consistent policy and session states. Option A is inaccurate as SMO handles state across OC layers. Option C is false. SMO is fundamental in any Maestro deployment. Option D is incorrect as failover is automated. Question 21. In the context of Maestro's deployment, Mr. Roberts is configuring security groups for large data center. He wants to ensure that policy changes propagate quickly and consistently across all SGMS. Which mechanism best supports this requirement? A. Using the SMO master's real-time synchronization capabilities to push policy changes immediately. B. Configuring periodic full backups on each SGM to apply changes incrementally. C. Relying on the orchestrator's schedule polling to distribute policy updates. D. Using manual synchronization commands on each SGM after policy changes. Answer. Correct answer A. Explanation. The SMO master is the centralized management object responsible for real-time synchronization of configuration, policies, and state across OSGMS, a security group enabling immediate consistency. Options B, C, and D introduce delays or manual steps, making them less reliable and slower than SMO synchronization. Question 22. Based on the information, Yasmine wants to optimize traffic distribution on her Maestro system using Layer 4 distribution. Under which scenario is Layer 4 distribution preferred over Layer 2 distribution? A. When dealing with only stateless traffic flows. B. When multiple flows share the same MAC addresses but require session stickiness. C. When switching devices operate only at Layer 2 with no IP awareness. D. When the network topology does not support VLAN tagging. Answer. Correct answer. B. Explanation. Layer 4 distribution leverages IP addresses and transport layer ports, TSUPHUB, allowing for granular session stickiness even when multiple flows share the same Layer 2 MAC addresses. Layer 2 distribution cannot differentiate flows beyond MAC, making it unsuitable for complex session-based traffic. Options A, C, and D do not justify Layer 4 distribution. Question 23. Considering the security group module SGMS, Istapark is tasked with ensuring hardware redundancy. Which hardware component is most critical for maintaining SGM redundancy within a security group? A. Redundant power supplies in each SGM. B. Multiple physical uplinks aggregated via LAC. C. SMO master running on a dedicated server. D. Use of SSDs for faster file access. Answer. Correct answer. B. Explanation. Multiple physical uplinks aggregated via LAC ensure network redundancy and load balancing between SGMS, preventing single points of failure and improving throughput. Redundant power supplies. Option A. Improve hardware availability but do not directly affect network redundancy. Option C is a software function. D. Affects performance but not redundancy. Question 24. Mr. James notices his Maestro system is experiencing uneven traffic distribution despite enabling Layer 4 distribution. Which advanced configuration setting can help him better balance flows at SGMS? A. Adjusting the hash seed value used for flow distribution. B. Increasing the VLAN ID range used in SGMS. C. Changing the orchestrator cluster mode to active or passive. D. Disabling the correction layer to prevent flow reshuffling. Answer. Correct answer A. Explanation. The hash seed value affects how flows are assigned to SGMS. Adjusting it can help redistribute flows more evenly by changing the hashing algorithm output. Option B impacts VLAN segmentation irrelevant to flow hashing. Option C concerns high availability unrelated to traffic distribution. Option D disables the key component designed to correct distribution imbalances. Question 25. From the perspective of initial Maestro implementation, what is the most critical step to ensure OSGMS can communicate securely and reliably with the SMO master? A. Configuring consistent VLANs and IP subnets across OSGMS and the SMO master. B. Installing the latest smart console on OSGM HUS. C. Enabling SMP traps on the SMO master for alerting. D. Set ASGMS to operate in standalone mode temporarily. Answer. Correct answer A. Explanation. Consistent VLAN and IP subnet configurations are essential to establish reliable, secure Layer 2, 3 communication between SGMS and the SMO master. This network foundation ensures proper synchronization and management traffic flow. Options B and C are helpful but not foundational. Option D disables cluster communication and is not recommended. Question 26. When analyzing the audit trails of a Maestro deployment is a lean and notices gaps in event logging during cluster failover, what is the most probable explanation? A. The SMO master was offline during the failover event, interrupting log collection. B. Audit logging is not supported during high availability events. C. Logging level was set to minimal during failover to conserve resources. D. Orchestrators buffer logs locally, causing temporary delays in audit trail updates. Answer. Correct answer, D. Explanation. During failover, orchestrators buffer logs locally, causing gaps or delays in audit trail updates until synchronization resumes. Option A would cause broader failures, not just log gaps. Option B is false. Logging is supported but may be delayed. Option C might happen but is rarely configured dynamically. Question 27. To what extent does enabling the correction layer improve traffic flow resilience in a Maestro cluster? A. It prevents any packet loss during hardware failures. B. It adjusts flow assignments dynamically to avoid bottlenecks and maintain session integrity. C. It encrypts all in-air EGM traffic to secure communication. D. It limits traffic flows to specific VLANs for segmentation. Answer. Correct answer. B. Explanation. The correction layer dynamically adjusts flow assignments based on real-time cluster health and traffic patterns, maintaining session integrity and avoiding bottlenecks. It is critical for resilience, especially after failover or topology changes. Option A is unrealistic. Packet loss can still occur. Option C concerns security, not traffic flow correction. Option D is VLAN management. Question 20. Rebecca is preparing to deploy a dual orchestrator environment. What is the key consideration to ensure efficient failover and minimal session disruption? A. Both orchestrators must run on identical hardware platforms only. B. Active and backup orchestrators must share synchronized configuration states through the SMO. C. A backup orchestrator should have a different software version for safety. D. VLANs must be disabled on orchestrator interfaces to avoid conflicts. Answer. Correct answer. B. Explanation. Configuration synchronization through the SMO between active and backup orchestrators ensures seamless failover and minimal session interruption. Option A is good practice but not mandatory. Option C causes compatibility issues. Option D contradicts networking best practices. Question 29. Within the framework of Maestro licensing, what is a direct consequence of exceeding the license number of SGMS on the system? A. SGMS beyond the license limit enter a degraded performance mode. B. Excess SGMS fail to initialize and cannot participate in the security group. C. This mode disables policy enforcement on all SGMS until licenses are corrected. Orchestrators automatically redistribute traffic to licensed SGMS only. Answer. Correct answer. B. Explanation. Maestro licenses limit the number of SGMS that can join a security group, or exceeding this causes unlicensed SGMS to fail at initialization, preventing their participation. Option A is not supported by Maestro design. Option C affects the entire cluster incorrectly. Option D is not automatic. Question 30. The primary purpose of the single management object, SMO, master in Maestro is to a. Handle all user access and smart console logins centrally. B. Coordinate cluster-wide configuration and synchronize state across SGMS. C. Replace the orchestrators during network outages. D. Encrypt all data traffic between SGMS and external networks. Answer. Correct answer. B. Explanation. The SMO master is the core of cluster management, coordinating configuration and synchronizing session and policy state across all SGMS. It does not replace orchestrators. Option C, which handle data plane traffic. Options A and D describe unrelated functions.